So the production possibilities from here, or in other words, production possibilities curve, is a curve or a tool or a way of visualizing and showing the relationship between the production of two different products in the market. So the imaginary world that we will create to suit this graph, because this graph, all it is about is basically imagine a country or a market, and imagine it only produces two different goods, two different products. Okay, I chose computers and phones. Okay, imagine it only creates two products, two different distinct products, because that's what this graph, this curve is meant for. It's not meant for 3 or 4 or 5, just two. And also imagine that it has somehow limited resources, which is absolutely normal. Every market, every country has limited resources. And so it's going to distribute the resources between the phones and the computers. So whenever you create computers, you have to take into account you're also creating phones. And so we have to create like an equilibrium between each amount of produced phones, that there's going to have to be some resources left for the computers. So automatically, when you have more computers being produced, then you're not going to be able to produce all that many phones. If you produce a lot of phones, you don't have that many resources left to produce computers. But it's going to be all shown on the curve. So there's computers and phones, two different products, and therefore we have two different curves. That's the number one thing you have to always remember. It's not like magical curve going out of nowhere and you can just do this and not understand what's going on. Of course you can do that, but you're gonna probably get confused. You have to realize normally the graphs in mathematics, they go in this direction also. They go left, bottom, right bottom, left, up, and so on. But in this case, it's very simplified. It only goes right and to the top. There's no negative numbers. It's all just positive. On the x and on the y-axis, as it would be in maths, it's all positive numbers, okay? The smallest thing is 0, which is nothing. And so, let me draw a sample curve. It can look like this in the simplest case, which is not the real case, or it might be the real case, but in most scenarios the curve is somehow bent, which I will also show. But the reasons for that might be shown in another video, because that's more complex examples that require more complex understanding and more complex experience with more problems. So this number one problem involves two things: production of computers and production of phones. And so each of the curves will represent one of the products, the number of produced products. Okay, so this curve will represent number of produced computers, and this will represent the number of produced phones. Okay, so we can choose 5 different points for each. First one will be 0 and the highest one will be 4. So we have 4, 3, 2, and 1. And just like there, we have 1, 2, 3, 4. Okay? And so you see that this line already is going to show us all the possible points. You know, the line basically is like, if we only had points, well, we could only draw connection to those points. From a point, we go horizontally and vertically and get how many phones and computers at that point, right? That's what this curve is about. You go to a certain point, and you go like 3 phones, and you go down, 1 computers. Or you go here, you see 2 computers, 2 phones. Or you go here, you see, you go here, you see 3 computers, 1 phone. Yeah? So that's the idea. Now, the curve enables you to have uncountably many points. It's all the different points. You can just point a point and then draw a line and see visually where approximately it is. So, this curve basically tells us that when we produce 4 computers, we don't have any resources left. We've used all our resources and there's 0 phones produced at that amount of computers. So we can produce 4 computers, but there's not going to be anything left. So we are going to produce 0 phones. When we produce 1 less computer, so 3 computers, we can produce 1 phone. When we produce 2 computers, we can produce 2 phones. When we produce 1 computer, we can produce 4 phones. And when we produce 0 computers, no computers at all, we can produce all the way 4 phones. And this shows you that actually in this case with this line, that is absolutely linear. It's a line, it's not a curve, it's a line, it's a linear curve, but it's not bent in any way. Well, it's absolutely straight. It's also connecting two axes with the exact same numbers. You see 1, 2, 3, 4, 1, 2, 3, 4. And the fact that this is a line, it's straight, and these numbers are the same gives us the fact that in this particular case, in this particular production possibilities frontier of this exact market, the resources for a computer is the same as the resources needed to produce a phone. That means when we take away one computer, we can bring in one phone produced. When we produce two less computers, we can produce two more phones, and so on. Of course, the curves are not always like this, but before we get into that, I'll also explain the resources. So, the curve shows you the max usage of resources. That means you're using all your resources. So whenever you are on the curve, that's the efficient point, and that's maximizing the market's resources usage. You're using all the resources that the market has to offer. It's all the resources that you can use, that the market can use to combine them into production of these two different products. So that means if you're using all your resources, you're always on the curve. You're always on the curve. The curve basically is all the different points at which you are using all resources. Okay, that's the purpose of the curve. Now, for example, if you are here on the curve, let me draw it down to show where it is located on the x and where it is located on the y. So for phones, but on this point we're doing three phones and we're making one computer. At this point, and it's already something I said a few minutes ago, at this point we're doing like two phones and we're doing two computers. And the same goes for every other point. We can go to this point, we can go to 3.5 computers, and at 3.5 computers, we do 0.5 phones. So you see, it's not even really full units always, but of course you should target to full units because there's no such thing as production of 3.5 computers, okay? You cannot just divide a computer into two parts. So, now, you see this curve shows us the efficient point or the market maximization where we use all the resources, and we see when we create a lot of phones, we don't have that much resources left to create more computers. We create very few computers. When we create a lot of computers, we don't have that much resources left to do more phones. Now, whenever we take a point inside the curve, that means inside the area, from any point on the area bounded by the curve and the axis that's in here, that's possible. That just means that you're not using all the resources. But why would you not be using the resources? It's inefficient, it's under usage of resources. So that's not clever to do. But it's possible. Then on the curve, that's maximization, using all resources. Now depends on how much computers and phones, what combination you choose to do. You're using all your resources, but you want to create more phones, or you want to prioritize computers, right? That's the question that this entire graph is about. But then if you want to realize some points outside the curve, that's not possible. You can never go outside the curve because unless the curve shifts, and then you are again inside the curve. Why? And by inside the curve, again I mean bounded by area bounded by the axis and the curve, so inside. Okay. If you go here, that's not possible because if you are out of it, there's not enough resources for that. Okay. So being outside the curve means there's no enough resources for such amount of phones and computers. That's not possible. You cannot do that. Okay? So there's not enough resources for that. That leaves us at the fact that economic growth means shifting out the curve. That's one more very important point to realize in this thing. So let me just delete this entire thing. Amend the numbers, which we just used a lot, but might confuse you in this next step, which I'll wrap it up with, because there's more to it, and that would probably be better led to another video, not to overwhelm you. So, just imagine we have some curve, and now actually I'm going to do a little different one. Usually bent curves are more realistic. Now, of course, you again locate the points exactly the same way, but you're going to see patterns that are different. You're not going to be like one less computer, one more phone. It's going to be a little more dynamic, okay? So it's not going to be always so linear and accurate and exact relationship that's absolutely linear. It's going to be a little more like the more you go towards the edges, the more compromise you're going to have to do on one of the products production over the other. Okay, so it's gonna be like the more you're getting towards the one edge, well, you're gonna produce just a little bit more of one product, but you're gonna have to lose the production of a lot of the other product. So it's not really efficient. So especially with this bend curve, it's good to be somewhere around here. Okay, not in the middle, rather in the middle. But that's not the point right now. What I wanted to say is economic growth means there's more resources. That means your options are no longer bounded by this curve, and you no longer have to only go around this curve in order to be at the space where you're at the edge of your resources using all of them. Because economic growth means the curve goes further from the origin. It moves outside by this. If you imagine a line or a line over which this curve was symmetrical, you just move the entire curve out. Okay, you push it out away in this direction, 45-degree direction. Okay, this is 90 degrees, so in 45-degree direction, you push out the entire curve, and it means before and after this arrow goes, the entire curve gets pushed out. And in such case, there's economic growth, which means we have more resources, and we can produce both more computers and more phones. Or we can just produce the same amount of computers, but we can produce, if we were here with the computers, or maybe we were here with the computers, so we were only doing this many phones, okay? But now we can do the same amount of computers, but because our resources shifted and the entire curve therefore shifted, we can do this amount of phones, okay? The same goes with phones. Well, we were at this curve, this was our limit before, but now there was economic growth, so more resources available for production of everything, and so we can do the same amount of phones, but we can do all the way this amount of computers, okay? So the more the curve shifts out, the more resources there are, and that's economic growth. That's very positive. And the opposite can happen when the curve shifts to the left. That's economic downfall, less resources, less ability to produce both of the things. So there's less material available to produce either of the two things. Okay, so that's good. Just remember, now ignore the shift and everything, just imagine there's just one curve again, no longer any confusing shift. Just remember, being outside the curve, that's over our resources, not possible, impossible. Being inside it is under usage of resources, but it's possible. And being straight on the curve, whatever point, is using all the resources, but deciding between are we going to do more of one product, or are we going to do more of the other product? And all the technical stuff, playing with the numbers and stuff, will be in another video where we'll be calculating some more concrete things along the curve and showing patterns according to different shapes of the curves.